My name is Tracy Purdy, and I had to do section 1.1, number 25. This is the differential equation that it gives you. This is just the original equation that it gives you that you have to manipulate, and this is the additional equation that it gives you. First, we had to verify that y of x satisfies the given differential equation. So this is the equation it gives you. I derived it using the chain rule, and I got 3x squared secant squared of the quantity of x cubed plus c. So then I put this equation into the original differential equation that's up here. So I got 3x squared secant squared of x cubed plus c equals 3x squared of the quantity of tangent x cubed plus c, and that's squared plus 1. So then I had to get them to equal each other, so I divided by 3x squared. Those canceled. So then I was just left with this. Then I realized that you could use the basic trig format to try and get the equation to equal each other. So I subtracted the tangent squared x cubed plus c from both sides, and I get the secant squared x cubed plus c minus the tangent squared x squared plus c. Then I wrote from basic trig identity of sine squared plus cosine squared equals 1. So then I divided by a cosine squared, and then I got tangent squared plus 1 equals secant squared of x. So then I subtracted a tangent squared, so this is the format that I use, is that 1 equals the secant squared minus tangent squared of x. Therefore, since what's in the variable or what's in here does not matter, it just still equals 1 as long as this argument and this argument are the same, so that the secant squared of x cubed plus c minus tangent squared of x cubed plus c equals 1, and you wanted it to equal 1 from this original equation that I got up here. So I found out that it can be verified. Then the next part of it, you had to determine the value of c. And this is, I just wrote the equations back down again. The equation that it gives you, the differential equation. I wrote down what, oh, sorry, no. This is the derivative of the original equation. Then this is the differential equation. And this is the extra equation that's supposed to help you determine the value of c. So I said that I plugged in 0 for x and 0 cubed plus c, which just gets you the tangent of c. And so y naught equals 1, so I said 1 equals the tangent of c, so I did the inverse tangent of both sides to get c by itself. So the inverse tangent of 1 equals pi fourths, so c equals pi fourths. And then I used a calculator, or yes, a graphing calculator on my computer to figure out that these are the different graphs that can be made from it, and that this one that's a little bit thicker is the pi fourths one. That's the main one that I had. So that is my number 25. Thank you.